Stoichiometry multi-step conversions. In this video, we're going to cover a few multi-step stoic problems, and it's really just like the one-step stoic problems, except you're going to do multiple conversions all at once. All right. Now you should have a sheet of paper here that's one page, double-sided, and I'll just go over two problems here. Um, so if you take a look at the middle, this is a fill-in paragraph with you starting with a balanced chemical equation. And in this problem, we're starting with 25 grams of C5H12, and we're trying to convert to molecules of CO2. We would look at the flow chart to figure out how many conversion factors we need. And really, the flow chart is going to tell you all of the information that you'll need for all of these blanks. Okay? There is a word bank on the left-hand side. And the one last thing I want to mention is that in the second paragraph, there is a typo. It says, consider the problem to convert 25 grams of C5H12 to grams of CO2. It's supposed to say molecules of CO2, so please make that correction. All right, so again, I'm going to go over two multi-step stoic problems. In the first problem, we have a balanced chemical equation, and it's asking how many grams of O2 would be produced starting with 2 moles of N2O5. Let's start annotating. We're starting with 2 moles of N2O5. We're trying to convert to grams of O2. Now, there is a scaffold here. The number of conversion factors required to solve this problem. How many do you need? Let's remember what we're starting from, moles of N2O5, and what we're trying to convert to, grams of O2. And look at the flowchart. Moles of N2O5, grams of O2. So we're starting from moles of one substance, and we're converting to grams of another substance. So this is where we're starting from and where we want to convert to. Notice that it passes through two arrows. We're first going to need to do this step, which requires a mole ratio. And then we're going to do one more conversion, and that's going to require a molar mass. All right? So it's basically just doing two conversions at once. The first conversion factor is a mole ratio. The second conversion factor is a molar mass. Okay, so we need two conversion factors to solve this problem. Let's write down what we're starting with. We're going to be multiplying and drawing a line. And this is our first conversion factor. In our first conversion factor, the unit that goes in the bottom is the unit that we started with. The unit that goes on the top is what we're trying to convert to. And in the first conversion factor, let's take a look at the flowchart one more time. We're going from moles of the first substance to moles of the second substance. All right? So we're trying to go to moles of our second substance. Our second substance is not N2O5, it's O2. Okay, notice that this is a mole ratio, which we already said from the flowchart. For a mole ratio, you're supposed to look at the balanced chemical equation. There is 5 moles of O2, and there is 2 moles of N2O5. According to the balanced chemical equation, 5 moles of O2, 2 moles of N2O5. Take a look at the units that cancel out. Moles of N2O5 and moles of N2O5 cancel out. But we're not done yet, because we are not at the final unit that we want. So, again, we need to do our second conversion factor. So here's our second conversion factor. The unit that we write down on the bottom is the unit that we already wrote, moles of O2. So we write moles of O2 on the bottom. And what are we trying to convert to in our second conversion factor? If you take a look at the flowchart again, now we're trying to go from moles of our second substance to grams of our second substance. Okay, so we are trying to convert to grams of our second substance in the second conversion factor. This, if you notice, is a molar mass because I have moles as mass. For a molar mass, according to the flowchart, we need to look at the balance, or we have to look at the periodic table actually. For molar mass, look at the periodic table. And we're trying to get the molar mass of O2. If you find O on the periodic table, you're going to notice that it is 16, but the molar mass of O2 would be 2 times 16. So that would be 16 times 2, which would be 32.00 grams of O2 for every 1 mole of O2. If you look at the units that cancel out is moles of O2 and moles of O2. We are left with grams of O2, and that's what we wanted to end up with. So we can go ahead and throw in our equal sign. So in this problem, what we have to do is start with 2, multiply by 5, multiply by 32, and also divide by 2. Okay? So 5, or 2 times 5 times 32 divided by 2. I am getting 160. So there is 160 grams of O2 that would be produced if we started by reacting 2 moles of N2O5. This is our final answer, so we can go ahead and circle it. The second problem on the second page. And in the second problem, we are starting with a new reaction. It's asking how many moles of O2 will completely react with 45 grams of C8H18. Let's go ahead and annotate this. We are starting with 45 grams of C8H18. We want to convert to moles of O2. Okay, we're starting with grams of one substance, and we're converting to moles of another substance. Let's look at the flow chart real quick. We are starting with, again, grams of one substance, and then we're going to convert to moles of a second substance. So this requires 2 conversion factors because it passes through 2 arrows. The first conversion factor will let you convert to moles of your first substance. The second conversion factor will allow you to convert to moles of your second substance. Okay, so we need 2 conversion factors here. The first one is a molar mass, and the second one is a mole ratio. We need 2 conversion factors to solve this problem. Let's start by writing down 45 grams of C8H18 times draw a line. The unit that's on the bottom of our first conversion factor is grams of C8H18 because that's what we wrote down already. The unit that we're trying to convert to in our first conversion factor, let's see. First conversion factor, we're trying to convert to moles of our first substance first. Moles of our first substance, C8H18. Okay, our first conversion factor, again, is a molar mass, and that means we have to look at the periodic table to get the numbers. We have to figure out the molar mass of carbon and hydrogen, and there are 8 carbons and 18 hydrogens. So let's add them up. What you should get is about 114. There's about 114.224 grams of C8H18 for every 1 mole of it. So we're going to write this number right next to grams. And this is how many grams there are for every 1 mole of it. So we're going to write 1 next to moles. The unit that cancels out is grams and grams of C8H18. We are left with moles of our first substance. But again, we have to convert to moles of our second substance. This is why we need a second conversion factor. So times and draw a line again. The unit that's going to go on the bottom here is the unit that we already wrote down. Moles of C8H18 goes on the bottom. The unit that we're trying to convert to in our second conversion factor, if you look real quickly again, in our second conversion factor, we want to convert to moles of our second substance. So we're going to write moles of our second substance. Our second substance is not C8H18, it's O2. So we're converting to moles of O2. If you see this conversion factor, you should recognize it's a mole ratio. And if you have a mole ratio, you should be looking at the balanced chemical equation. How many moles of O2 are there? Well, according to our balanced chemical equation, it's 25 moles of O2. How many moles of C8H18 are there? According to our balanced chemical equation, there's two moles of C8H18. The unit that cancels out is moles of C8H18, moles of C8H18. We are now left with moles of O2, and that's what we wanted. So we can go ahead and throw in our equal sign. Okay, let's type this in a calculator. We're starting with 45. We are multiplying by 25. We are dividing by 114.224, and we are also dividing by 2. So what does that give us? 4.92. So that's what you should end up with when you type in all these four numbers. 4.92. And the unit is moles of O2. So 4.92 moles of O2 will completely react with 45 grams of C8H18 in this reaction. Alright, the rest of the problems you can try on your own, and you may want to compare it to the final answer before you turn it in.